In this lesson, we're going to be solving this problem. This problem is under angular motion. Here, the problem reads as follows. A rotating disk accelerates uniform from 20 revolutions per minute to 500 revolutions per minute during 3 seconds. Calculate angular acceleration, calculate average angular velocity, angular displacement during 3 seconds, and the number of revolutions. Here, we are given this rotational per minute and also this rotation per minute and these seconds. So here let us separate it. We're given n1 to be 20 revolution per minute, then n2 it is 500 revolution per minute, and also are given the time here, it is 3 seconds. Then here that's only what we are given. Then we have to find the angular acceleration. We have to find the average angular velocity. We have to find the displacement and also the number of revolution. That's what we have to find. First, we have to convert this to revolution per second. Here n1 it is 20 revolution per minute. Then put 1 minute is equal to 60 seconds. This 0.33 revolution per second. Then n2 is equal to 500 revolution per minute. Then same 1 minute, it is 60 seconds. This 8.333 revolution per second. Now we've converted it. We have to calculate the angular velocity 1. It is 2 pi then n1. So 2 pi n1 it is here, put brackets 0.33. Then this is gonna give us angular velocity 1 to be 2.07 radi per second. Then let's calculate the angular velocity 2. It is angular velocity 2 is equal to 2 pi then n2 here, then is equal to 2 pi, then we put this 8.33, then this will give, it is 52.34 radi per second. That is our angular velocity. Now let us calculate this now, the angular acceleration. How to calculate it? We'll say angular acceleration, it is equal to angular velocity 2 minus angular velocity 1 divided by time. This is substitute the angular velocity 2, it is this one, 52.34 minus 2.07. Then we divide by the time. Time, it is this 3 seconds. Here it's gonna give you 16.76 radi per second squared, like this. That is the angular acceleration. Now let's calculate the average angular velocity. We will say average, then angular velocity 1 plus angular velocity 2 divided by 2. That's how you calculate average angular velocity. Then you put angular velocity 1, it is 2.07 plus the angular velocity 2, it's 52.34 divided by 2. Then this will give 27.21 radi per second. That is the average. That's the average angular velocity. Now the statement said calculate angular displacement during 3 seconds. Then let's calculate here the formula to calculate the angular displacement. It is angular displacement is equal to angular velocity 1 plus angular velocity 2 divide by 2, then close bracket times by the time. The formula is like this. So since you see this part, all this part, it is equal to an average angular velocity. Here, this equal to this. So we'll put this like this. We'll say 27.21 like this. Then we times by the time. The time is 3 seconds. Then this will give 81.62 radi. Give this. Then now they say must calculate the number of revolutions. Then the number of revolutions will say the average number of revolutions is equal to n1 plus n2 divided by 2. Then n1 it is 0.33 plus n2 it is 8.33. Then this divided by 2. It gives average to be 4.333 revolution per second like this. Then you take this 4.33 revolution per second like this. Then you times by this time. This time is 3 seconds. Here this cancel, this seconds cancel. You only left with this revolution here. So we say this 433 times 3. It gives 12.99 revolution, of which it is 13 revolution like this. That's how you calculate this problem. That's how you calculate this problem.